Hello, I'm Dr. Roslyn Oluwaseun Ogundokun from Suwani University of Technology, and I'm here to make a presentation on the title Classification of COVID-19 Chest Radiograph Using LSTM RNN Optimized with Grey Wolf Optimization and Modified Grey Wolf Optimization. And I'm presenting at the 12th Annual Conference on Computational Science and Computer Intelligence. So these are my presentation outline, background of study, problem statements and motivation, research contribution, data sets, description, proposed model architecture, Grey Wolf optimization, modified Grey Wolf optimization, LSTM RNN configuration, performance, which is LSTM RNN plus Grey Wolf optimization, and then discussion, conclusion, and references. So as a form of background, chest radiography is an affordable and widely accessible imaging tool for diagnosing respiratory diseases, which COVID-19 also include. Then the manual interpretation of X-ray images can be time-consuming, and then it is also subjective and also error-prone one. So that led to the automation of deep learning models that can support clinical and also improve diagnostic accuracy and efficiency. So there is a growing need for fast, accurate, and automated COVID-19 detection method. And high-dimensional X-ray data often contain redundant features which can reduce model performance. Then effective feature selection can enhance classification accuracy while reducing the computational cost. So the main contribution in this study was one, to develop a hybrid LSTM RNN model for binary classification of COVID-19 and normal CRX images, to also apply the Grey Wolf optimization technique. And then the Grey Wolf optimization technique was also modified for feature selection in this study. We evaluated the model performance using the accuracy, precision, recall, F1 score, and also negative predictive value. And we demonstrated that the computational efficiency improved using Grey Wolf optimization. So the data set that was used in this study was a balanced data set that had 7,232 CXR images, and then we had all images resized into 50 by 50 pixel, and then we convert it into the gray scale. Images were flattened into 2,500 dimension vectors and normalized. Also, our splitting was 70 to 30, 70 for training and also 30 for testing. So this was the proposed model architecture. We input our data set, and then we use the stratified split method for the splitting of the data set. We preprocess the data set. We use both the modified Grey Wolf optimization technique and also the normal Grey Wolf optimization technique, and then we propose to deploy it. So the Grey Wolf optimization technique is inspired by the hunting behavior of Grey Wolf, and it is used to identify the most relevant feature by optimizing the binary features selection mask. And then it also helps to reduce dimensionality and also enhance model generalization. So the modified Grey Wolf optimization that was introduced enhanced the exploration and exploitation strategies to improve convergence speed. It also achieved faster optimization with minimum loss in accuracy, and it's also more suitable for resource-constrained environments. And then the LSTM RNN configuration was, well, the layer of LSTM was with 100 memory units, and then we introduced a dropout layer to reduce overfitting, and then dense output layer with softmax activation was used for binary classification, and then the model was trained using the ADA optimizer for 100 epochs. And this is the confusion matrix of the proposed model, LSTM RNN with gray wolf optimization. And then the performance table shows that in terms of performance, the LSTM RNN with gray wolf optimization performed better in terms of accuracy, and the in terms of precision for the normal, they had the same value, but for the COVID-19, the LSTM had higher value against the modify. The normal grey wolf used with hybridized LSTM RNN had the highest precision value over the LSTM RNN for the modified grey wolf model in terms of the COVID-19. Then also the recall for normal shows that the grey wolf optimization performed better than the modify in normal, and then in COVID-19, the modified grey wolf optimization technique performed better than the standard grey wolf optimization technique. So the model behavior is that the balanced performance there was balanced performance in the LSTM RNN used with grey wolf optimization for all the classes, and then the modified one, the higher sensitivity of COVID-19, and then we have fewer false negative values. So the grey wolf LSTM achieved the highest value overall for accuracy, which is 95%. Then the modified grey wolf LSTM achieved slightly lower accuracy, which is 92%, but significantly it reduces in training. So the modified one trained lesser than the normal grey wolf. Its training time was lesser. So both models demonstrated strong COVID-19 detection capability. Then the grey wolf optimization technique provided strong feature selection performance leading to high accuracy, and then the modified grey wolf optimization technique reduced computational cost by approximately 21%, making it more efficient. So the modified grey wolf optimization LSTM is ideal for rapid development in resource limited settings. Just like we have mobile application, we can use this modify grey wolf optimization LSTM. And then the standard one, standard grey wolf optimization LSTM is better suited for application requiring maximum accuracy. So we trade off the high accuracy to a faster model, which is the modified grey wolf optimization LSTM. So in conclusion, both grey wolf optimization and modified grey wolf optimization effectively enhance LSTM RNN performance for COVID-19 classification. So the modified grey wolf the modified grey wolf optimization technique offered a strong balance between speed and accuracy. And then this work demonstrates the value of combining deep learning with meta-heuristic optimization for medical image analysis. So in future, we propose to use this modified grey wolf optimization technique and hybrid LSTM RNN for larger data sets and also for multi-class classification. So these are my references. Thank you for listening.